Good morning, class. In our last class, we discussed about the hybridization and its types. Today, we'll learn how to predict the type of hybridization in a certain molecule by using a formula. So, tips to predict the type of hybridization of central atom in a molecule or ion other than complex ion. So, let us see what are the different steps involved in it. Step 1 is add the number of valence electron of all the atoms present in the given molecule or ion. So in first step, what you need to do is you need to add all the valence electron, that means the last electrons present in the outermost cell of all the atoms present in that. Now in step 2, in case of a cation, so if there is an ion and if it is having a positive charge, that is a cation, subtract number of electrons equal to the charge on the cation. So what you need to do is you need to subtract whatever charge is there, and in case of an ion and if it is a negative ion, add number of electrons equal to the charge on the ion on the anion. So if there is an negative charge, that is anion, you need to add whatever charge is there. Okay, now in step 3, that is in step 3, number 1, if the result obtained in step 2 is less than 8. Okay, so over here, if it is a cation or an anion and if the result obtained is less than 8, divide it by 2 and then find the sum of the quotient and remainder. Okay, so you need to divide by 2 and you need to find the sum of quotient and remainder. Okay, now number 2, if the result obtained in step 2 lies between 9 and 56, so if the result of the total number of valence electron comes between 9 and 56, you need to divide by 8 and find the first quotient q1, divide the remainder r1 if any by 2. So first you'll divide by 8, then you'll find q1 quotient 1 and remainder 1, and if the remainder is not 0, other than that, you need to divide by 2 and you'll find the second quotient and add all the quotient and the final remainders. It will be understood by when you solve the problem. Okay, now let the final result obtained in 1 or 2 be capital X. Now that is, X is the sum of the quotient and remainder. Now the type of hybridization is decided by the value of X. Now whatever value of X will come, that will decide the type of hybridization. Value of X2, if it is 2, then type of hybridization is SP. If the value of X is 3, type of hybridization is SP2. If the value of X is 4, then type of hybridization is SP3, like that. 5 SP3D, 6 SP3D2 and 7 SP3D3. Why it is 2? Because S and P. Why it is 3? 1S and 2P, like that. Okay, you need to understand and you need to remember these values. Now we'll clear this rule by using an example. Say for example, if you have got beryllium chloride. Now first you need to do is, since it is a neutral atom, neutral molecule, so you'll find the total valence electron. In beryllium, in the outermost we have got 2 electrons because electronic configuration is 1s2 2s2, we can say. Okay, and chlorine has got 7 electrons in the outermost, as we know, because it's a halogen which has got 7 electrons. So beryllium is 1, so 2, okay, and into 1 because only one atom, plus chlorine we have got 7 electron in the outermost, so since we have got 2 atoms, so we multiplied by 2. Okay, so 7 into 14 plus 2 will come as 16. Now this value 16, and since it lies between 9 to 56 according to our previous rule, we need to divide by 8. Okay, 16 divided by 8, which will come as exactly 2 quotient and remainder is 0. Okay, now the sum of these two, quotient and remainder, 2 plus 0 will come as 2. That will be the value of X. Now since the value of X is coming as 2, the corresponding value of hybridization is SP. Okay, so this is how we can predict the type of hybridization in molecule. Similarly, when you have got ICl4 minus, okay, this is a negative ion, we can say. So first, total number of valence electron, since both are halogen, they have got 7 electron in the outermost, so 7 into 1, because only one iodide atom. Chlorine, we have got 4, 7 into 4, so 28 plus 7 will come as 35. Okay, now since this is a negative ion, we need to add 1 electron to the total valence electron, so it becomes 36. Now the number lies between 9 and 56, so we need to divide by 8. So we divide by 8, we will get the quotient as 4 and remainder also 4. Okay, now since there is a remainder 4, it's not 0, you need to further divide by 2. So it is further divided by 2, which will come as 2. This will be a quotient 2 and remainder 0. Now the addition of Q1, Q2 and R2, okay, because this R1 has been further divided into Q2 and R2, so 4 2 plus 0, 4 2 plus 0 will come as 6. Since the value of X is coming as 6, the hybridization is sp3d sp3d2 sp3d2. Okay, next, assignment 16. Predict the type of hybridization of the following molecules. So in a similar way, however, we have seen the example, you need to predict the type of hybridization in these following molecules. You need to so step by step. Okay, one is beryllium fluoride, carbon dioxide, phosphorus pentachloride, NO2 minus, CO3 2 minus, NH4 plus, NH3, BF3, SF4, C2H2, this is acetylene, IF7. So complete this assignment and send it in my mail.